board, here we go. Rational equations. So we've got two scenarios to talk about. Sailor's going to be disappointed because it's not 10, but it's 2. All right, so scenario 1 is I have 2 fractions only, Colin, for goodness sakes. Can we take the book off of our hands?
Colin, take it off.
For example, 3 over x plus 1 equals 9 over 4x plus 5. Now, this is one of those things where this is one scenario. I'll show you a little shortcut method that'll work in this scenario, but the second scenario that I'm going to show you will always work. So you can take your pick which one you want to use. Yeah. Okay.
Is the second one longer? It's always longer.
All right. 2 fractions only set equal to each other. There is nothing else. What we can do is we can cross multiply to solve. Y'all love to cross multiply. Yes, I don't know why students love to cross multiply.
I've crossed multiplied almost like never.
All right, so you can only do it. Students always want to cross if it's equals. If you're adding or you're subtracting or anything like that, you do not cross multiply. You only cross multiply when it's equal.
I feel like we learned it and then we just don't use it. I remember learning it.
Yep, there you go.
Yeah, I would try to do it.
All right. Look, you're using it now. Thank you, 6th grade teachers, for teaching us how to cross multiply. Okay. Remember, as you cross multiply, it must be distributed if there are multiple parts here. So what I'm going to do is I'm going to do this. Distribute. Colin, try to be a little bit madder, please. 12x plus 15 equals, tell me what it equals. I hope, I don't just hope, if you cannot solve this equation at this point in your math career, what do I do first? Subtract 9x. So now I have 3x plus 15 equals 9. How do you solve that? Subtract the 15. I know I'm running a little fast through this, but I hope that once you get an equation set up, this is old hat to you.
So we're solving for x here?
This is exactly what I'm doing with my 1A kids right now. Okay?
1A.
All right.
Wait, which part?
All right. Solving the equation. Yeah, solving the equation. All right, guys. If I have 2 fractions, and I did start out with kind of an easy example, but if we have 2 fractions here, no matter what those 2 fractions are, can you cross multiply and solve?
Yes.
All right, then let's move on. Even if the 2 fractions look like this. Why is this one different? The x up top. When I cross multiply,
You get it.
ooh, I'm gonna have a quadratic. You're so welcome.
So you have to set it equal to 0?
So exactly, 2x squared plus 5x.
Yes, 5x.
Distribute that x through.
You didn't write that.
Look at the pen. It doesn't want to write that x today. Okay. Guys, this is exactly what happened yesterday, y'all. I need you up here. All right. I'm going to move this 8 at the same time also. I have 2x squared minus 6x minus 8. What multiplies to negative 16 but adds to negative 6? Yes, take out a 2 first. That's good. Good job, Courtney. Now it's a much easier factor. That is, and because there's no leading coefficient, it's negative 4 and positive 4. That what? It was what? Thank you, Donovan. Thank you. So appreciated. Looks like an Etch-a-Sketch line. All right. So each one goes to 0, right? That, because 2 will never equal 0, you can ignore that part. Same as, Maddie, you can look at it like this also. If I divided both sides by 2, it would cancel here, and 0 divided by 2 is 0. No more 2. So 2 solutions, 4 and -1. More than 2 fractions. All right? Here's what we're going to do, and I want you to think about something for just a minute. If you have a scenario where you have
Oh, Jesus.
if you have a scenario that looks like this, do you notice that every single denominator in this equation is the same?
So you just add the top, right?
So if it's all the same, then the numerators must also be the same. Because it's an equation, they have to be, right? Always, they have to. If all the denominators are the same, if every denominator you see is the same, drop them off and set the numerators equal to solve. Okay, so 2x equals 12 by Maddie. Hello, Justin.
I'm Maddie. Hello.
Got lost in the way to class.
All right. So x equals 6, yes? All right, that is not, do we all agree that is not a hard concept?
No.
Now,
That's it.
clearly,
We're wrong.
that's not all. We're going to have some different bottoms. You're exactly right. So the question is, if the bottoms start being different, what does that do for my equation, and where do I go from there?
Do you have to find all the LCD and all three?
Absolutely. We're going to LCD the whole equation. Okay? We're going to LCD the whole... You okay, Drew?
Yeah, I'm fine.
It was on the video too.
Let's say...
There'd be like 3 sacrificial lines going on.
Let's look at this. This is more than one fraction, right? Now this same technique will work with just 2 fractions. Okay? So if you don't like to cross multiply, this same technique will work then as well, okay? So as I look for the LCD, remember before I find an LCD, everything needs to be what? Factored. What do you see there that can be factored?
X squared minus 9.
How does it factor?
X minus 13.
Ooh, y'all on fire. All right. So now, what's the LCD?
X minus 3, X plus 3.
Right? All right, so give everybody what they need to have the same bottom. What does the first fraction need in order for it to have the LCD? X plus 3, top and bottom. How about the second one? It's good, right? It's good. It's all good. What about the last one? Top and bottom. You know we always have quadratics coming back. Do we agree that the bottoms are all the same? So you got to be careful. Yes, you're going to have to remember this is a distribute kind of thing when I have a scenario set up like this. Okay?
6x plus 18.
So, and I'm going to write it out. I'm going to take it in 2 steps, Evan, even though you're a step ahead of us. I'm just going to write the numerators here so you can see where everything's coming from. Is anybody confused by that? All right, Evan, what'd you say the left was?
6x plus 18.
Mm-hmm.
Minus 4x squared.
Mm-hmm.
Minus
6x plus 18 is 4x squared plus 12x? I would move these, yep. Because I want my leading coefficient to be positive so I can factor, right? 4x squared plus 6x minus 18. You can. Good job. Now this becomes a chapter 1 problem. Don't you love how that happens?
When you say chapter 1?
Quadratics. Remember chapter 1 was all about quadratics. You don't remember? He's always there, Donovan. All right. Yep. Yep. What multiplies to negative 18 but adds to positive 3? Positive 6, negative 3. It's a factor. So 2x squared plus 6x minus 3x minus 9.
Can we like cross out the 2 at this point?
Yeah, you could, theoretically. All right, 2x, somebody said take out. That's right. I keep the middle sign. What am I taking out of the second 2? 3. What am I left with? 2x minus 3, and x plus 3. Is anybody confused at this point? Yes. Everybody goes to 0 except, of course, the 2, because 2 is never going to equal 0 no matter what you do. Right, Cullen? Oh my gosh, would you quit death staring me, please? 2x minus 3 equals 0, and x plus 3 equals 0, which means x could be 3 over 2, or x could be negative 3. Tell me what you think.
I think this is great.
Is there gonna be a problem with all 3 of these are different?
For this too. Let's say I have something like several of you see something like this and you go, but I don't know what to do because that 7 doesn't have a denominator. What's the LCD? That's Donovan, I heard that, as did all of YouTube world.
Wait, what did you say?
So, x minus 2 is what it needs, that's the LCD, and so then I would just set the numerators equal, okay? I won't bore you by finishing to work that out. 5. Just to show you, this is scenario number 1. If I did not want to cross multiply it and I wanted to do the LCD method for this, what is the LCD here? So what does the first one need? What does the second one need? Essentially, I have cross multiplied. It's the same thing. Right? All right, let me give you your assignment.